All right, example 2 talks about the zeros. Zeros are the same as or equal to x-intercepts. So anytime you see that word zero, those are x-intercepts. So in this example, the x-intercepts are when x equals -4 and when x equals 2. Let's say I wanted to get everything on one side and make it equal to 0. Then I would add 4, so I would get x plus 4 equals 0. And then here I would get x minus 2 equals 0 by subtracting 2. Now I have two factors. I have x plus 4 and x minus 2. So my zeros help me find a factored form, which if I multiply that out, I get x squared minus 2x plus 4x minus 8. Simplify that to get x squared plus 2x minus 8. Oh, wait, you should be going, that looks familiar, because that is what we got in the beginning. So our x-intercepts of a graph actually tell us the factored form of an equation. Okay, so moving right along to the next example, how does that work? So now when we want to solve the equation, if we set equal to 0, so move this 42 over by subtracting. So minus 42 equals 0. So it always has to be set equal to 0. So step 1, make it set equal to 0. Then we factor it. So we think about splitting the middle term here. What multiplies to get negative 42 but adds to get 1 would be positive 7x and negative 6x. So then we factor out what they have in common. And we do have the same thing in the parentheses. So we have x minus 6 times x plus 7. Remember, that was a special case. So if you remember that that was a special case, you can actually skip these 2 steps and go straight to the last step. And then, so the zero product property says that if I set each one of those equal to 0, I will find my answer. So if I am solving, so that's the difference here. When it says solve, I need x equals. Okay, that's solving. If it says something like factored form, that's where I have the parentheses. Okay, so that's your difference there. But when I solve this, it is 6 and negative 7. So try the next one, setting equal to 0, and check your answer on the next slide.